Construction is a very important stage in a safer school project. All the work from the previous stages, prepare, plan and design, is undermined if the construction work is poor or the materials are weak. There are 3 steps in this stage. Step 1, build local skills. Step 2, monitor construction. Step 3, practice and communicate safety. These steps often happen at the same time. Steps 1 and 2 are needed to make sure the school will be strong enough to withstand hazards. Step 3 creates a culture of safety at the school and in the community. The first step is building local skills. Safer school buildings must be built with hazard-resistant construction techniques. These techniques are ways of putting a building together. They are tested techniques based on buildings that have used them and survived disasters. For example, engineers now know lintel and sill bands can hold brick walls together when earthquakes shake. In high wind areas, engineers know to turn the short side of the school towards the prevailing wind and to securely tie the roof to the walls. Even something as simple as a tiny bend in a piece of rebar matters. In an earthquake, that little bend can keep a concrete column from crumbling. Local builders need training programs to teach them about what happens to buildings in disasters. And they need to know what hazard-resistant construction techniques work to keep buildings standing. The best way for local builders to remember is to first learn the technique, then practice it at a demonstration site with builders who are already skilled in using the techniques. It is best practice for training programs to value and include local knowledge and building practice.
Trying to get local artisans like plumbers, masons, carpenters, they are really scarce to come by. So when we get into the community, we try to make all those laborers or artisans who work with us re-equip themselves and learn other skills, like the basic one, such as the sieving of the sand. For all that they know is that we get the sand, use it for construction. At the end of the day, the debris in them will rot and they will end up exposing voids. If it is a concrete that you've cast, you end up seeing that you have lots of voids, which will end up leading to cracks and stuff in the structure. So with this basic thing that they've now learned, they are actually teaching their community members that we need to save our soil before we actually use them for construction so that we can get the best quality.
Community members may also want to know how to adapt hazard-resistant construction techniques to their houses. The more school construction resembles their housing construction, the easier the transfer will be. But even if the techniques used on the school project are not easily adapted to housing, such as when the project is a school retrofit, training can show local builders and interested community members what will work to make their homes safer.
जो एनसेटले तालिम दिनुभन्दा अगाडि के छ भने त कि अहिले पनि छ कस्तो नि घर बनाउँदा मान्छेहरूले पिलर र बीमहरुको कनेक्सन जोइन्टहरु हुन्छ नि त त्यो जोइन्टहरुलाई चाहिँ नि जस्तो 3 इन्च हुक 4 इन्च हुक गरेर डन्डीको मोटाइको जुन जोडाइ छ त्यो जोडाइ पुराएको हुँदैन अझ जस्तो डन्डीको मोटाइको थिकनेस अनुसार अब 60 डाया चाहिँ नि हुनुपर्छ भन्ने छ जस्तै बीम र पिलरको जोड्ने र त्यसलाई नै फलोअप अहिले पनि नगरिरहेका छन् तालिम जुन प्राप्त नगर्नु भएका हाम्रा मिस्त्री दाजुभाइहरूले हैन तर हामीले चाहिँ त्यहाँबाट पश्चात तालिम पाइसकेपछि हामीले पूर्ण रूपमा त्यही प्रविधि मात्र अपनाइराखेको हो.
Local engineers, government officials, inspectors and other specialists may also benefit from training. In many countries, these specialists may not know the hard-earned lessons from disasters elsewhere. Local inspectors and engineers may be especially interested in what they should look for in buildings to make sure they withstand disasters. Step 2, monitor construction. Make sure the materials used are strong and match design specifications. Monitoring is also needed to make sure the construction is high quality. Engineers who study why disasters damaged schools often find it is because of poor quality construction. Sometimes bricks are so weak they can be broken by hand. And lumber arrives warped and unusable. Other times, workers add too much water when they mix concrete, or they leave rebar, the reinforcing steel in concrete, exposed to rain and air where it rusts and weakens. To avoid problems like these, the design engineer explains the school design and its hazard-resistant techniques to the construction workers. The program manager makes sure the design engineer is available to answer questions builders may have during construction. The design engineer also needs to approve any design changes, so these changes do not weaken the school. The program manager also hires an independent inspector to monitor the construction. The design engineer may be a good option. Hiring an inspector is the most important ethical responsibility a program manager has in the construction stage. Ideally, this inspector, or the design engineer, is at the construction site every day. At minimum, the inspector needs to be on site during important stages, such as before and after the foundation is laid, when the walls are raised, and when the roof is attached. When construction materials are delivered to the site, the inspector checks they are of good quality and strength. Also, during construction, the inspector watches to make sure workers are carefully following the school design.
The contractor did not follow the design that we gave to them. So, but our project engineer is very strict in terms of that. So when she found out that it was not the design that she gave to them, she immediately told them that we have to stop that and we have to work it out again.
By closely monitoring the implementation of the construction of the school can consider as a safe school, because you can inspect the critical period of the construction implementation in the site.
While community members don't have the expertise to do construction monitoring and inspection themselves, they do play an important support role. Community members are around the construction site every day. The program manager can give the school management committee and parents a checklist of good and bad construction practices that they can review. When potential problems are spotted, the community can quickly let the inspector know. Even older children can observe the construction site from a safe distance and identify the project's safety features. This gives the community a sense of ownership and strengthens the monitoring process.
It is very important, it's very essential that we must be involved. It is because that the building itself is not anyone's possession, but it is really the children, it is really the students who will be occupying it, and therefore it is very important that they must know the essentials of being safety. The building itself must really be of good standard materials must be used, and therefore monitoring is essential and beneficial.
I learned many stuffs like the building construction itself, the primary roofing, like that, and we should know our safety, and we should consider everything in the around and inside the building itself. Safety first. Safety first.
The last step, step 3, is practice and communicate safety. Safer school projects are an opportunity to create and practice a culture of safety that continues after the end of the project. During construction, the contractor puts up fences and other barriers to keep curious children from getting into trouble. The program manager or engineer also explains to everyone what tasks need to be done and how to do them safely. The program manager gives special attention to making sure community volunteers who may not know much about construction conditions learn the safety rules. Even for onlookers, the project should promote safety. Signs or posters can be a great way to explain how the school is being built to protect workers and future students. Construction tours for curious community members can also create opportunities to show the new hazard-resistant construction techniques the workers are using. Creating a safety culture in the community can continue even after the last nail is hammered and the last wall is painted. When program managers invest in this step, it can make a real difference to the future safety of the community. Everyone can think of creative ways for the school building to demonstrate a culture of safety. School evacuation routes can be prominently displayed. A lintel beam can be painted with a label saying earthquake banned, and a sign can point to the school's elevated foundation in a floodplain. It may be possible to leave a cyclone strap painted a bright colour to show how to stop a roof being blown off in high winds. During Stage 4, construction, training workshops build local skills, and the program manager ensures an inspector and even the community monitor construction. Everyone practices and communicates safety. With the school construction winding down and the community aware of its safety features, it's time to celebrate. As the project moves into the post-construction stage, everyone will need to make sure the school remains safe.